Good morning and welcome to our Math 8 Writing Equations review. So today, before we move on in our lessons, what I thought would be a good idea is for us to review writing equations specifically in slope-intercept form, okay? And so I'm going to review with you how to do that from a graph, from ordered pairs, and from a table today. So remember, slope-intercept form and writing equations is just what it sounds like. It's the format y equal mx plus b, where m is our slope and b is our y-intercept. And then coming up in some of the lessons, at least in my class, and I think wherever you go to school, you're going to find that slope is also going to be named the rate, and the y-intercept is going to be named the starting amount or the initial value, depending on what text you're working with and honestly what problem you're working with. So today, let's start with doing an example of finding the equation from a graph. And so what you want to do is exactly how the title of this sounds. To write an equation in slope-intercept form, you got to find the slope and the y-intercept. So for the sake of the video and space, I'm going to use m for my slope. And let me remind you that finding slope on a graph, you need to use rise over run. So rise over run means when we have 2 points on a graph, we can figure out our rise, which is how far up or down that we would travel to get from point to point, and our run, which would be how far left or right. Well, the problem sometimes is that we don't have points already labeled on our graph. Excuse me, I'm going to get more markers here. So you have to label your own. So as is the case with this graph, we got to find 2 spots where there would be a good place to put a point. And you want to put points right on the corners. So for example, I see a corner where the line goes through 4 corners right here. Another spot might be right here. And there are several throughout. But those are the 2 that I'm going to choose. So the idea for rise over run is if I'm going to travel from this dot to this dot, I'm going to start with rise. So how far up or down would I travel? Well, I would travel down 1 square. So down 1 means negative. So -1 would be my rise. My run now, how far left or right would I go? I would travel right 1, 2 squares. And since I'm going right, that's +2. So my slope is going to be -1/2. Now, if I had done that and it was larger numbers, I would want to see if I could reduce that. But since it is -1/2, that cannot be reduced. That's my slope. Okay, the second part of writing an equation in slope-intercept form is to find the y-intercept, or our b value. Let me remind you from a graph, y-intercept means where does this graph, right here, running diagonal, cross the y-intercept that runs vertically. And so they cross right here at this spot. That would be the crossing spot. What number would that represent on your y-axis? And that number is +1, 2, 3. It's not labeled as 3, but you can count the squares there as well. Now, the answer to this, the equation we would be looking for, is y equals, and instead of writing m now, we're going to write the number we found, -1/2 x, and then instead of writing b, we'll write the number we found there, so +3. We use plus because that was positive. And this is our equation from a graph. Okay, so that's one thing we want to review. The second thing that we're going to review today is how to write an equation in slope-intercept form from a set of ordered pairs. So again, same format, so we need to find the slope and we need to find the y-intercept. So let me remind you that slope from ordered pairs is going to use the formula y2 minus y1 over x2 minus x1. And those come from these labels. So if you have two ordered pairs, this is x1 because it is your first x value. This would be y1 since that's your first y value. This is x2 because it's the second one, and y2 because it's the second ordered pair. And then you plug in the values according to your formula. So y2 would be negative 2 minus y1, 4, would go on the top. The bottom would be x2, which would be 0, minus x1, which would be 3. And then you want to simplify. Negative 2 minus 4 more would give us negative 6. And 0 minus 3 would give us negative 3. And then you want to reduce or simplify. Well, negative 6 divides negative 3 evenly, and a negative divided by a negative gives us a positive 2 for our slope. So halfway done. Now, to find y-intercept from ordered pairs, we have to solve for y-intercept. So our y-intercept, we use the general format y equal mx plus b again. And what we're going to do is we're going to fill in y and m and x with numbers. Well, m we just solved for, that's 2. Y and x come from your ordered pairs that are listed, and you can choose either one. I tell my students to choose the one that looks easier. And I'm going to actually choose x2, y2 because there's a 0 in there, and I know 0 is an easy number to work with. So under x, I'm going to put 0. Remember, this means multiply here because they're right next to each other. And then for y, I'm going to put negative 2. And then I'm going to write down plus b because that's what I'm solving for. Okay, so 2 times 0 is actually 0 right here. Bring down your negative 2 and your plus b. Okay, so now it's saying 0 plus what number gives us negative 2? And most of us can do that in our head and know that it's negative 2. If you wanted to, technically you could cancel this 0, so subtract 0. And subtract 0, well, negative 2 minus 0 is negative 2, and that is our result for b. Now, what's the equation then? You've done all of the work. The final answer, the equation, remember, is y equals, our slope comes first, 2, and then our x, and then our y-intercept is negative, so we're going to say minus 2. And this would be our final answer, our equation from ordered pairs. Okay, last but not least to review is finding the equation or writing the equation in slope-intercept form from a table. So same way we start, we need the slope and the y-intercept. So slope from a table is going to use the exact same formula for our slope from above. We still use y2 minus y1 over x2 minus x1. And so what you can do is actually choose any set of ordered pairs. To keep consistent with my class, I just start with the top 4. So this is our x's, so this is our first x, that would be x1. Here's our second x, x2. This is our first y, so y1. Second y, y2. And so then we plug them into the formula. So y2 minus y1 would be 4 minus 1 on the top. x2 minus x1 would be negative 2 minus negative 4 on the bottom. And then you simplify. 4 minus 1 is 3. And negative 2 minus negative 4, minus negative really cancels out, making that an add. And so now negative 2 plus 4 is going to end up giving us positive 2 here. And so 3 over 2, you could make that a decimal depending on, but we're going to leave that in an improper fraction, and that's as simple as it would go. And so our slope is 3 over 2. Now, the other thing we need to find for slope-intercept form, again, would be your y-intercept or your b value. And let me remind you from a table that your b value, your y-intercept, is going to be the value of y where x is 0. So if it were an ordered pair, it has to be 0, comma, a number. And so on a table, what you're searching for is, oh, here's where x is 0, but what we need then is the y value on the y-axis. So our y-intercept would be 7. If the 0 is not shown, you can either use the pattern to work backward or forward to find the 0, or you would have to go and use our method from finding ordered pairs and use y equal mx plus b. But the 0 is there, so we can use it. So our b value is 7 here. And our final answer would be y equals 3 over 2, our slope, x, plus, since it's positive, 7. And this is our equation in slope-intercept form from the table. Okay, hopefully you find that helpful as a review. For my class, we are then going to work on our writing equations worksheet and practice before we move on in our lessons. Hopefully you have a great day. If you need anything, please email me.